right, guys, go ahead and get your notes titled and dated. And like I said yesterday, we're going to be talking about scientific notation. The first part to discuss with scientific notation is what it looks like for a number to be written in scientific notation. So there's certain requirements that have to happen for a number to correctly be written in scientific notation. The first thing, though, is that you understand that scientific notation takes numbers that are extremely large or extremely small, and it makes them easier to read and write and compare. Now, I'm not going to take long periods of time for you to write things down, so you'll need to pause the video so that you can make sure you get all the notes written. So 6.92 times 10 to the fifth power is a number that is written in scientific notation. There's a few requirements of a number to correctly be written in scientific notation. So this leading coefficient of 6.92, this front number has to be 1 or greater, but less than 10. So we could have any number in that first spot that is 1 or greater, but less than 10. So we could have 7.57, we could have 9.999, we could have 2. But that first term has to be a number 1 or greater than 1, but less than 10. Then it is always going to be a multiplication problem. So that is a times symbol. So 6.92 times. And then this last term is always going to have a base of 10. So 10 is always going to be this number right here. And then that will always be raised to an exponent. Oops, spelled that wrong. So you have a number that is being multiplied times 10 raised to an exponent. And this number has to be between 1, but less than 10, times a base of 10 raised to an exponent. Now, this is huge, guys. This is a key part. This is different than our exponent rules. So that exponent can be negative or positive. So it can be negative or positive. That's different than our exponent rules, guys, that we just got done with, because we had to flip all of the negative exponents. But with scientific notation, it's okay if the exponent is negative. So make sure you put big asterisks around that. This is very, very important. So we're going to look at a couple and decide whether or not they are written in scientific notation. So I'm going to have you get down a couple more examples of a number written in scientific notation. So 4 times 10 to the 7th power. And 2.35 times 10 to the negative third. So again, this is between 1 but less than 10. Then we're multiplying. And then it has a base of 10 raised to any exponent. So that is correctly written in scientific notation. All right, so we're going to skip ahead to 4-2, and we're going to actually investigate scientific notation numbers, okay? So, all right, so we're going to take numbers that are written in scientific notation, and we're going to write them in expanded form. So what that means is we're going to actually write them as the numbers that they actually are. Guys, changing numbers between scientific notation and standard form is super, super simple. The only thing you're going to do is move the decimal. So if I have the number 5.6 times 10 to the 5th, what this exponent is telling me, it's telling me how many times to move the decimal, and it's telling me which direction I need to move. So if this exponent is positive, then we're going to move the decimal to the right. So we're going to make a number that's bigger than 5.6. So I'm going to take that leading coefficient, 5.6, and I'm just going to move that decimal. I call them loop-de-loops. So we're going to move that decimal 5 times, because that's what the exponent tells me. So I'm going to take this decimal, and I'm going to move it 5 times to the right. So 1, 2, 3, 4, 5. So the decimal's back here at the end of my number. And then hopefully you know that we put zeros in as placeholders. And then the only other thing we need to do is rewrite that number without the loop-de-loops. So that number is going to be 560,000 when we're done. You can put the decimal back here at the end, but remember, any whole number always has a decimal at the end. So 5.6 times 10 to the 5th is the same thing as 560,000. So it took a bigger number and it wrote it in shortened form. Okay, so let's look at another one. So again, if it's a positive exponent, we move the decimal to the right. So I always start off with rewriting that leading coefficient of 4.3. And then that exponent tells me how many loop-de-loops I need to move. So I'm going to move 1, 2, 3, 4, 5, 6, 7, 8. So my decimal's back here at the end of my number now. I'm going to fill it in with zeros. Now I do require that you rewrite the numbers without those loop-de-loops in there. So I'm going to rewrite this. Remember, every 3 digits there is a comma. So this is going to be 430 million. And then again, the decimal is still back here if you want to put it at the back. So see how it took a really large number, 430 million, and we could write that shortened as 4.3 times 10 to the 8th power. All right, I'm going to put another one up here, and I want you to pause the video for a second and try it on your own. All right, so we take the leading coefficient of 6.8, and then our exponent tells us we need 3 loop-de-loops. 1, 2, 3. So 6.8 times 10 to the 3rd is the same as 6,800. So this would be our final answer. So that's how you take a number from scientific notation and write it into standard form. So that was really, really large numbers. So now we're going to do scientific notation that has a negative exponent. So you see what that looks like. Okay, as you can see, this is already written in scientific notation, so we need to write it out in standard form. The only difference between this and our other problems we just did is now the exponent is negative. So before, the exponent was positive and we moved the decimal to the right. Now that it's negative, we're going to move the decimal to the left. Okay, so same concept. So I'm going to take that leading coefficient of 6.2. Gotta leave myself some room. And I'm going to move it to the left, 11 spots. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then we fill them in with zeros. Now the one main difference in negative exponents and positive exponents is when we rewrite this, we have to leave the decimal in the front. We have to. Because this is a number that is smaller than 1. This is a teeny, 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 tiny number. Okay? So it's important that we leave that decimal out front. Now, I don't know about you, but I have a hard time rewriting this. So I'm going to count how many zeros I have. 1, 2, 3, 4, 5, 6, 7, 8, 9. I have one too many zeros. That's my fault, guys. So there should be 10 zeros in the front. So I'm going to write 10 zeros, 3, 4, 5, 6, 7, 8, 9, 10. And then we still have to write that 6 and that 2 in the back. So 6.2 times 10 to the negative 11th is this really teeny tiny number when it's written in standard form. All right, so let's do another one. So we're going to take 9.21, and my exponent is negative 4. So I'm going to move the decimal 4 times to the left. 1, 2, 3, 4. I'm going to fill it in with circles, or not circles, I keep saying that, with zeros. And then I have to rewrite it. So remember, the decimal's in the front. I have 3 zeros, 1, 2, 3, and then 9, 2, 1. So 9.21 times 10 to the negative 4th is 0.000921 written in standard form. I'm going to put 1 up here. I want you to go ahead and pause it and try it on your own. All right, so we're going to take 3.472, and our exponent tells us to move it 8 places to the left. 1, 2, 3, 4, 5, 6, 7, 8. Fill it in with zeros. And then we have to rewrite it without the loop-de-loop. So that's the decimal, 7 zeros, and then 3, 4, 7, 2. All right, so we're going to recap on the next video. So now you need to open up the next video that is linked.